with Penang Science Cluster. You might know me because we have been to a lot of schools in Penang. And there's another teacher here, teacher Annabelle. So let us open a video to show us who we are actually. Okay. Okay. Hello. Can you guys see me? I think, yeah. But most of the time, the video will be
showing
the green screen, which is the hardware. So this is it. This is what you guys will be seeing for the rest of the session today. All right. So make sure before you start, you have the hardware, the Mecha Uno set with you, and for those who are new, who already know about, already joined the previous class, make sure you have the module with you. I think the module you can get from the Arduino programming Google Classroom. If you haven't joined, if you don't have, you can just still join us. I will still follow us because I will share the module here in the screen. So in 3, 2, 1. Okay. Wait. This is delaying. Okay. So now you guys can see two camera. One is the hardware, another one is the shared screen module. Project 2 running LED. Okay. Just a quick recall for those who are new and also those who joined last week. So do you guys still remember how well you guys understand about Arduino before we go into today's project? So Annabelle, a few questions to test them.
Wait, you give me some time to think.
Okay, so make sure you guys, we give you guys 1 minute to recall back what is Arduino, and then how far you guys know Arduino. Just recall back everything. So we're gonna give you 1 minute, and it's at the same time we're gonna prepare a few questions from our side. Okay, are you guys ready? The first question is gonna be very simple, which is, what does resistor do? What does a resistor do? Anyone? Control electric flow. Any more other answer? I would like to see, control the electric flow to reach the LED. Lagi. Others? Reduce the electric current. I'm interested to know from those who are new today. So at least we can understand your level of understanding on Arduino and electronics, so that it will help our webinar today. Okay, correct. So for the first question, what does a resistor do? Resistor control the flow of electric current throughout the circuit. Okay, so that's for those who forget or can't recall. So you guys can see inside the chat. So you can see a few answers. All of them are correct. Thank you, Muiz, Mune, Tong Lim, and Wong Xin. Sorry if I pronounce your Xin En. Okay, sorry if I pronounce your name a bit wrong. Okay, that's the answer for the first question. The second one. What is meant by pin mode? What is pin? What is mode? So this pin mode is actually is a code. It's a code in Arduino. So for those already familiar, already experienced like coding in Arduino IDE software. So you guys should know. So should encounter the word pin mode. So what is pin mode represent? Let's start pin mode. PIN from ODE. Pin mode tu semua. Right. Pin mode tu apa? Code that is used to light up the LED. Okay. Others. Banyak. And more. So there's another one. The digital pin in the input or output is plugged in.
Digital pin.
Lagi. Any other answer? Okay, so I think that's the two answer that we get. So what is pin mode? It's a code, correct? It is used to light up the LED.
No, that's not pin mode. That's another code.
A code is used to light up in an LED is another code. So before that code, we need pin mode. So pin mode is used to configure a specific pin to behave either as an input or output.
On point. This answer is on
Yes.
point.
So if for those who don't know what is pin mode or can't really explain, but they understand but can't really explain, you can see the answer from Abdul Muiz. Pin mode is used to configure a specific pin, which is you can see on the microUNO there's a lot of pin from pin. Basically, we most of the time we will be using pin number 2. Bit here. Okay, yeah. So pin number 2 until pin number 13, I guess. So that are the pins which is we are referring to. So a specific pin to behave either as an output pin or input pin. Correct. So you can code that pin either to become an output input. So what is output input? For those who are new or later, you guys will understand more when we try out some of our project today. All right. The third one, I think that is going to be the last one, right? So then we can start. The third one, what is digital write? The level of hardness, difficulty of digital write. To explain digital write, I think a bit similar to pin mode. So let's see. What's the answer? What is digital write? Okay, we have two answers here. First one from Muiz, to write a high or low value to a digital pin. Then another one is similar around there. I mean, right, a high or low value that is pin. What do you think, Annabelle?
It's correct.
Yes, correct. So digital write is we are declaring the component. Either you want it in a high state or in a low state. So what is high state means? What is low state means? High state means okay, like you can assume maximum current flowing through that component, which is, for example, if you're using LED, the LED gonna light up. Whenever you code as high, LED gonna light up. Whenever you code as low,
Let's draw this again.
LED gonna turn off. So Annabelle will show a drawing about high and low. Okay, then we're gonna continue our project for today.
So this is the digital signal. So when you are high, it's here. So it's like this is 0, this is 1, this is 0, this is 1. So the 0, 1 in coding here, it stands for high and low. So when you put high, it means it will completely turn on. And if you put low, it will be completely off. So yeah, I think that's all for the explanation of low and high.
Yes.
You just based on this graph. It's
So
very
one-
easy to understand.
One represents maximum current flow. 0 means there's no current flow. As simple as that. Alright. So for today, if you see on the slide that we are sharing to you guys, so it's written as project 2 running LED. Last week we stopped at project 2, but so we're going to continue from project 2 this week. Alright. So first, for those who are new and those all of you guys, so before we go to the hard software part of the project 2, so we need to recreate their circuit. So based on the screen, let us know if you cannot really see the screen. We will also demonstrate how to recreate the circuit. So you can open the Meccano box and you can start to take out the LEDs as shown inside this slide. So let us know if you cannot see. I will try to zoom the slide a bit. Oh, yeah.
I think you present.
All right, present. Oh, yeah, this is better. So Annabelle, guide them.
So I'm going to unplug all.
Yeah.
Is Xingyuan in? I remember Xingyuan's connection is different from
Oh
others.
yeah. Sinuan connection a bit opposite. It's like from different universe. The resistor need to be connected to the positive side of the LED.
Okay, so we put the Maker Uno aside first. So what you need for project 2 is 3 LEDs and 3 resistor. The resistor you are going to use is 220 ohm. You can see in this pack of components, it's the one that has the most number of resistor inside. So you can see the color as well. It's red, brown.
As shown inside the slide, also red, brown.
Yes. So you take 3 red, brown resistor, which is 3220 ohm resistor. So we'll connect the LED first. So how you connect LED is you just connect them to different numbers. So it's either you connect 20 and 21 or 22, 23 or different numbers. They can be 18 and 20 also can, but don't connect them in the same numbers. Yeah. So when you connect, you also need to remember which number is positive and which number is the negative one. So I will connect at 20 and 21.
We believe you guys already know how to detect the terminal negative and positive from the LED. Yeah?
Then my yellow is 15 and 16. Then my green LED is 10 and 11. So for mine, all my
Positive.
positive leg are all on the left. All the negative is all on the right.
Yeah. Easier. So if you choose to put the negative leg of your LED to your right side, so make sure the rest of the LED also the negative terminal to be on the right side. So it's easier for you to know.
So is everyone done till here?
We give you guys around 30 seconds to just, if you want to follow exactly how we are doing, then should be fine also.
Just let us know by saying.
Yeah, if you're done, you just say yes or okay.
Yes, okay, some other.
If you don't know, don't shy to ask us. Even you can ask us to repeat. Yes.
Okay,
exactly.
So repeat from the start. Wait. Okay, so if you are the first time, so the breadboard connection is this way. So this negative row is all connected, and this positive row is all connected, but negative and positive is not connected. So it's like how to simplify.
Rama Arun. I know him. I mean, I know the picture.
I also know him.
Okay. So, what she meant is the holes, the pinhole throughout the negative terminals. You can see this is the negative terminals.
So like this.
All the holes inside already have a thin metal plate which connecting each one of them. So it means if you put a current at the current or electric, wire at the first pin, so the current can flow until the end of the pin along the negative. But it won't happen. It won't jump to the positive pole. It will go along the negative only.
Yeah. So positive has its own conductivity, which is this row only. So wherever you connect here, like if you put a big supply here, then here will be supplied with the big supply. It's like a wire, but the wire you can add on extra wire. Yeah. So for the numbers is 1, 2, 3, 4. I mean like 1 and 2 and 3 and 4 and 5 are all not connected, but F, G, H, I, J is connected together. So this one is connection. Their connection is in row. This connection is in column.
So let us change the slide for a better view.
It's not in this.
Oh yeah, it's not in this. It's okay. For now, you just follow what NML is doing. You take your LED.
So you take
make sure you know which is negative and positive.
So the longer leg is the positive, the shorter leg is the negative. It's like you do chemistry, cathode, anode.
Yes.
But cathode is positive, right?
Negative.
Okay.
Cathode is pendek. Anode also. Yeah, anode is longer. Cathode to cathode.
Anyway, positive is long, negative is short leg. So I will plug in my positive to
pin number
20 and negative to 21.
So for now, the positive is on one side, negative is one side.
So both are not connected together actually. So it's for you to connect to other components. Okay, now I will take my yellow LED and connect to 15 and 16. And the same thing for green, I will do it for 10 and 11. So just now I said my all the LED mix. For the left side is positive, the right side is negative.
Okay tak, Syahira? Yay!
Okay, now we will connect the resistor. So resistor is to control the current flowing to the LED so that you don't burn the LED. So this resistor can be connected at the positive or negative, but here we will connect it at the negative side of the LED and connect it to this negative flow. So instead of putting another wire, we just directly use these legs to connect the negative and to the negative of the LED.
Okay, so as simple as negative flags of LED will be connected to the resistor.
Yeah, just treat it as a wire, but this wire has 220 ohms.
Yeah. So same goes to the rest of the LED.
Resistor.
Hmm.
So if you're able to do this, you can do the same for all the LED. So I will connect it at a 16 and then negative. And then another one is 11 and negative. So in this way, when you're connecting in the same number with the negative leg, means you're connecting the negatives together. I think you need to draw.
Come again?
I mean, if you are connecting to the same number, it means all are connected together.
Now, if you guys realize, all the resistor leg are pinned inside the negative row. So it means all these resistors are connected. Current can flow along through because, like we say, they are along the negative, with all the pins inside the negative are connected to each other already with a metal plate underneath the breadboard.
Yeah, maybe you should show the metal plate one day.
Yeah, one day we're gonna maybe later after we finish project 2, we will try to show you the metal plate inside the breadboard. So next, wire.
So next you will take
Mechanism.
4 wires. Okay. So okay, I need to put down already. Oh, and so. Okay, so you're gonna take 4 wires. So I will use the black one for connecting the negative to the ground.
Yes. Hi Andrea, finally.
While the other color
Hi Andrea.
will be for the pins or for the LED. So these LEDs are going to connect to a digital pin instead of 5-volt. So we will connect this LED, this wire, to the positive leg of the LED, which is mine is 20, 15, and 10. So all you need to do is just connect at the same number, like this. Let me see. So the other end will be connected to the Maker Uno, which we will do it later. So do the same thing for all the LEDs. So for the positive leg, mine is 15. I'll connect another wire on any holes of 15. And then same for sorry. Is everyone okay?
Just a quick check. Are you guys on track? You can say okay.
You can say no.
Yeah, if no, say no, Yeah. Alright.
Okay. So now we finish. Not finished. I mean, we've done connecting the positive leg of the LED to wires. Now we'll connect the negative row here with one black wire, which indicates it's actually going to connect to ground.
Just FYI lah, for information, you can use any color, any wire to any pin lah.
Yeah.
Color doesn't affect anything.
It's just you need to know what color does that indicate. Oh yeah. Okay, so I'll put it down. I put this side. Okay, put this side. So you can now take your metal uno. Okay, so for the ground, which is the black wire for mine, I will connect to ground first. You all know ground is where? Metal uno ground is here.
GND.
GND here. So that I think there's 2 pins of ground here. Add 2 pins here and 1 here. But we usually connect to here. And then
Connect to the ground near the 5 volt.
Then these 3 wires will be connecting to what is the value that we are going to connect?
Pin 7, 8, 9.
So we are connect to 7, 8, and 9. So the red one is the same. Its ground is just at the different position. It works the same. It's like it's labeled as ground. Okay.
You can try to put to
Okay,
other
I
ground.
will try. Okay, so then your red, as shown in the slide, the red LED is connected to 7, 8 is connected to yellow LED, and 9 is connected to green LED. So based on your LED, you connect to the respective pins. So red will go to 7, yellow will go to 8, and green will go to 9. So mine is crossing all over, but it's okay.
So we give you guys 30 seconds to complete. Okay. Okay, where's the black one between? For now, we put the black pin to the ground above number 13. You can see number 13.
So number 13 is here. So there's a small ground here, or you can put at this ground.
As long
They
as
works the same.
it's ground lah.
Yeah, as long as you're connecting to the one label ground,
Hmm.
not the one label 13 5 volt. Or if you connect to 5 volt, that is really bad. I think I connect back here, easier for you all to see. Yeah, the ground connect back.
So just to make it align with all of us, so let's just follow the module. So you guys just connect to the ground near the 5 volt or 3.3 volt. So there are two I think 2 pin of ground. So you guys connect to the second pin, yeah. So like how we are we pin here. I think okay, like this. Yes, second hole.
Is it with this better?
But This time the camera is quite clear.
Yeah, I think no autofocus. Hey, I cannot find the correct angle.
Ah, that should be fine. Okay.
So is everyone on the same page as us?
Right. Okay. So now it's time to connect the Mecha Uno
To your laptop. So you will take your USB cable. Ding ding ding. This is a messy cable. And then you can see this connection, right? You just plug in this micro USB. And then this USB-A, USB will connect to your laptop.
Yeah.
Yeah, so when you hear the ding ding ding, so you're done connecting the Maker Uno to the laptop. Just say yes, no, yes. Then we will proceed to the next step. Okay, so now we will go into the software part because we've done the hardware part. So last week we actually did the first software, right?
Yes, the first part of the software.
Yeah. So this running LEDs, it actually have
Give me a
two.
second. Let me adjust that.
They have two ways of writing the software. So last week we did the simple one, which is labeling, not labeling, I think writing them manually. So now we will be doing a bit advanced, not really advanced, like it's just a bit extra coding, extra knowledge also. So for this code, we will be using for statement. So for statement is that you are doing a loop. So we know that void loop is actually will be running your code continuously, but for the for statement, you can actually control the numbers of looping that particular code.
You guys might thought like what is he saying about, right? So basically, comparing to last week, this week we're gonna code a bit more. We call that intelligent way,
Yeah.
in a more professional way,
Shortcut way.
shortcut and more intelligent way compared to last week. Last week, if you have a small error, it's hard for you to detect as the error, etc. For this one, the software itself will be like sort of semi-automated, something like that. So let's do that first, then we will explain in detail. So you guys can follow us. So the first thing I'm gonna write here is, okay, just a check. You can see the screen, right? You can see the software that we are typing in. So I'm now typing in INT. Yes.
So because we are going to use the for loop, for statement, so we will declare an extra integer for the extra value.
So yeah, int represents integer. Integer bermaksud number bulat. I mean whole number. So this I.
It's not whole number lah. It's real number. Cause other got negative
Oh,
also.
number include negative juga.
Really? Sorry, I mixed up.
Okay, so this I now is a variable, correct?
Yes.
Yes, it's a variable. This variable can be anything. In this case, in this situation, it will be a number, integer. Okay, jom. So pin mode 7 output. So to make it easy and save time, I'm going to copy and paste this stuff. Highlight.
Control C.
This is
Control V.
Copy. Click here. Paste. Then paste. Then just change the value 8. Then change the value 9. Okay, next. What loop? So we're gonna use the for
statement.
For I. Okay, this is okay. Let me recall back. Initiator, condition, action.
Is it action? I think it's not.
Yes, action. Action by 1.
It's increment. Initialization, condition, and increment. So the first one is your starting value. So what is the number you want to start? So because we are using pin 7 to 9, so we will start with I equals 7. And then the second one, you forget your I.
I. Oh yeah.
I.
Yes. I.
Okay, so then we have the condition. So the condition is like when it run this condition, is it true or false? If it's true, then it will go to the increment.
Okay, let us put a note for you guys. Okay, so how to put a note? Just a backstroke.
2 backstroke.
Double backstroke.
Yeah, so it's a comment.
Okay,
it's not backstroke. It's forward.
Backslash.
Forward slash.
Forward slash.
2 forward slash.
Where's forward slash?
At the question mark there.
This is
change color
because it should be forward slash. This is forward slash. I equals to 7 is the initiator. Is it the correct spelling? Initialization. Try to pronounce initialization 3 times as fast as you can. What happened to your tongue actually?
Initialization.
Some people can't really say that. And it's equals to 9. Call as they call this as well condition. So what is the condition that we give them? They need to obey the condition, something like that.
They need to fulfill the condition, then only can move on.
Yes, move on. Then the last one is I plus plus or U. Plus plus, it means
increment.
Increment, increase by 1. In this case, increase by 1.
Yes.
So plus here is 1 actually, plus 1, positive 1. So since it's 1, we don't really put 1. If it's 2, we have to put 2. 3, 4, 4. You want to reduce then negative 1 or negative 2 or negative 3.
So the actual I plus plus is actually I equals I plus 1. This is the real format. That one is a short form of I equals I plus 1. So it's like you are adding another one from your current I.
If your current I is 7,
so it's like then it will add 1 and then it becomes 8.
If you write plus 2, it's gonna add 2, 7. direct jump to 9, direct jump to 11, direct jump to 13. Okay, go.
So now, after a for statement, you will need to have an open curly bracket to write your code.
This is open curly.
So
curly.
whatever is in the curly brackets, it will run that particular code based on the initialization, condition, and increment that you stated.
Yes. I'm gonna make a shortcut because I'm lazy to type.
Only once. Oh yeah, still got low. Because we are going to make the LED blink, one LED blink at a time.
Okay, so let us know when you finish type and with any questions. If you finish type, you just say yes. We will explain if you have any questions, and then we're gonna download the code inside the macaroona and see what happens.
Where is the mouse? Menu. Oh.
Okay, I'm sorry because we forget that you guys are, some of you are new. So for those who are new, you need to have an Arduino IDE installer. It's a software, looks something like this. Let me show you guys here. So yes, looks like something like this.
So you need to
Download.
download the file and install in your laptop or desktop to run the software and type in the code.
Okay, so how to download?
Okay.
How can I increase or decrease the size of font? Ah ha ha.
So what we did was just zoom in and zoom out.
Yes.
Yeah, so it's control and then your mouse
Scroll.
scroller.
So something like this. We hold the control, then we just scroll this. Right?
Yeah.
Okay, anyway, back to the installer. Shahira and another two students, those who are new, you just type Arduino IDE here, and then you can see Arduino software IDE. Click. If make sure you know what type of laptop you're using, either a Windows or MacBook, Apple. So you go down here, and you can see Windows installer for Windows 7 and up if you're using Windows, and then if you're using MacBook, then you go for Mac OS. Click, then you download, then you install in your laptop.
So when you download, it will be a zip file or some file. So you have to open and run the application. You will see the file.
Let me show you guys. I click this thing here.
No, I mean yeah. So when you come here, you just press just download.
Just press this download lah. Unless you want to contribute. You want to contribute, or if you don't want to contribute, just press download this thing. Then you gonna download as something like this. You just save whenever you want. You will see the name of the installer is Arduino 1813 Windows. If Windows, you save. For now I'm just gonna save on desktop for just to show you guys. So you're gonna download just wait until it finish. You're gonna take just like a few, not even 1 minute. If your internet connection is quite strong, I believe all of you guys, if you manage to join the Zoom, Google Meet, so there won't be any problem for the internet.
So when you finish downloading, when you click, it will pop like the user active something, like it's like a warning or some kind of warning.
I just show in folder. I want to see. Okay, I will show you guys. It will be something like this. Okay, so you will see something like this. I believe you guys can see this. Arduino IDE, just
Double click.
right click or double click, just run an administrator, or you can just open and just click yes, yes, next, 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 tick and next, tick and next,
And then install.
until install. Okay, so we give you guys. Okay, where is the low? Let us know if you're okay. Let us know if you already download Shahira, and then we have who else?
So Rama Arun is done. Mo is also done.
We have 3 students new today. They are Shin Eun, I guess.
And who?
Yeah, Shin Eun, Hana, and Shahira.
Hey, Hannah, I thought last week she joined.
Really? Oh, I think so. All right. So anyway, do download the software and try out.
We will wait for a few more minutes for those who are still downloading and also coding the software. I mean, like typing the code.
Okay, so next will be
Verifying,
verify first.
and then we will upload it to the Maker Uno. So let's verify. You may save this code if you want. Save it as what? Running LED software 2. So after done compiling, you upload.
Okay, upload.
And
Wait. I think
so
okay, anyway, there's an error here. Expected bracket at the end of input, so we need to have another curly bracket to close.
now we only have one curly bracket to close the for segment. So we need another one to close the void loop. And also remember to choose the correct port.
Okay, for those who are new, whenever you plug in your USB cable, doesn't mean that you already connected your Maker Uno to the software. First, you need to do the configuration step, which first will be click tools. So everything is within the tools setting. Click tools and board. Make sure you choose Arduino Uno, and again you choose tools and port, and choose a COM port. If you have more than one, you choose one, and make sure you are choosing the correct one, you click get board info. Okay, now we didn't get any info, so it means we select the wrong one. So we try
So you
another one.
can see the bottom green color border here. It says
Native
native
serial
serial
port
port.
can't contain info
It
means
means it's you are not choosing the correct COM. So we'll try another COM and we will press get bot info again. So if no nothing pops up, then another COM.
so it means that for
So
our Make
when
Uno,
yeah.
COM6 is the correct COM port.
Well, what do you mean by you have problem at pin mode 8?
Your problem is on your code or your hardware.
Hmm. Which one? Okay, so now is it successfully uploaded to your Maker Uno? Oh, it's running now. So you can see after you uploaded, this is what you obtain. So it's like the traffic light. So it's like the traffic light. So besides the LEDs, you can see it's blinking. You also can see this built-in LED here. It's also blinking the same sequence as the LED. So my red one is pin 7. So when 7, the LED 7 also light up as well as the red one.
Okay, let us explain a bit how these four
3,
this for what for loop works.
4 statement
Four statement loop. Okay, so first, if you see, to look back on the increment statement is 7, so it will increment.
It
I mean,
will,
initialization statement is 7, so you're gonna start with pin number 7.
yes.
So, and any LED that connected to pin number 7 gonna light up first. So whenever it light up, this is the rule that you need to follow.
Why your delay gone already? One? So there should be another delay. I guess we accidentally deleted or something happened. Ooh, that's creepy. So we will run again. Upload again. So why I can't upload it to my Arduino board?
Have you done the configuration step? Click tools, click port, and click com. Oh, so what it shows you? What it tells you?
Yeah, what is
Error
the
or anything, or you cannot detect port? What is the error? Can Mune share screen?
so
Can you share
if you want to
screen?
share screen,
Yep. Or it was not declared in the scope. Exit this one. This report will show I. Oh, you didn't put INTI, I guess. You didn't put the first top one. INTI. Did you do this?
did you declare the variable?
Integer I. Ah.
So that's why. So when you did not declare any extra variable for your for statement, it will not run because it does not recognize what is that.
Yep.
So there are two types of declaration here. So if your declaration on the top here, this variable is known as the global variable. Well, if you declare under void setup, then you can only, it is known as the local variable, so means that particular variable that you declare inside void setup can only be used in void setup only. But if you declare here, which is known as the global variable, you can use it in void setup as well as void loop. Yeah, so you can see here it says what global variable use 11 bytes. It means
memory.
of memory, leaving 2037 bytes for local variable. So
Okay. Back to the code in void loop.
yeah, so now you see there's a delay of on and off, so you can see it's on, off, on, off, on, off.
Okay. For Rama Arun, is either you didn't do the configuration step, click tools, click board, or you need to unplug your micro USB cable, plug into another port in your laptop, and try do the configuration again. How about for the new students, those who just joined today? Can you guys download the apps, and you are you trying out the software? Are you trying out the code? Wait, let us know if it works. I cannot upload the sketch. Why I can't upload? What it shows now, just now is the INT. Have you uh did you add in the INT?
What can't I up? Maybe you try to press
Okay, this
upload
one is
again.
Mune. Now it's Muiz. Muiz, what's the problem? What is the error?
Yeah, what did it write in the what's it called?
In the status.
Area.
Can you show us what is the error?
Yeah, just press copy error message and then paste here. Yes, now I can. I changed the part. Okay, great. Oh, someone is showing us something.
Wait. Monet is showing us something.
Do you want to share the screen?
Can you share the screen? You just share the screen.
Oh my god, what is happening? It's very blurry.
It's not that quite clear. You cannot really see anything.
Oh, are you using your phone instead of your laptop? That's why you are doing this.
Oh, okay.
I nampak.
Can you show it again? Show us again. Just that
Yeah, sure. What about others? Others are
okay,
able to.
let us call a random name here. Ha. How about ang anjing? Great.
Yay!
Hannah.
Hannah or Hannah? Hannah.
Okay, let us ask her. Your name is Hannah or Hannah?
Hannah, it feels like the.
So anything? I mean, how about yours? You face any problem? Can you upload the code? Does the LED works? Great. Then we have who else?
Zero.
Sinro. How about yours? Then we have Yitong, correct? Yitong Lim.
Yitong. Yitong.
Yitong.
Mm.
Okay, wait. Let us see. Just now, when what?
Muiz.
Muiz,
Muiz.
can I present the screen? Yes, you can. This all means present now. We
Yes,
will like
yes.
to see
So
the
we will
problem.
stop present first. So now you can present and show us your problem.
We okay.
Oh,
Alright, you can see that. So what's the error? What's the problem?
no, you're using Android. Did you connect your Arduino to your? Is this a what? What is this? Is it a
An Arduino Droid.
compilation finish? But uploading cannot.
No Arduino bound found. When board found. So how normally you connect your Arduino Droid with the Arduino board? Using your Bluetooth or what?
Bluetooth?
Yeah, I don't even have Bluetooth in Arduino. So how basically you connect that?
Yeah. We are very curious.
Using your cable, is it? What cable?
Are you using
OTG?
Oh,
What is that OTG?
the conversion, the
Converter.
cable.
Okay.
Not
So have you plugged your OTG cable yet?
I think he did. That's
Then why not found? Try to search.
Are you able to choose the port? But I think there's only one port.
Okay. Board type. No, board. Is it Arduino? Uno, correct.
Is there any more configuration you can do?
Then COM. You don't really need COM, right? COM4, COM5. We never tried Arduino Droid yet.
Yeah, never tried before.
You try to unplug and plug again. Cable.
The last time you did was using Arduino Droid as well. I mean, like last week I think last week you asked, right? Mm.
So any other possibilities that you can try, Moise? Before this I can upload, but now I cannot. You can unplug. How?
Restart.
Restart. Restart what, phone or
Phone lah.
maybe
Maybe you try to restart the phone and then you come back to us again. That's maybe one of the choice you can try.
because maybe have a clash or anything. Anyway, let's continue.
Okay, sure.
So let us know, Moise, after you try.
So
Alright.
maybe we shall explain. Yeah, we shall present now.
Explain this. You can explain this. Okay. Okay, how this LED can light up, and okay, first the question is how the LED can jump, the light can jump from one LED to another LED. Second is why each LED is blinking before it jumps. First, the first question is why the light can jump from one to another is because the what do you call that? For statement.
So your initialization, the first one is I equals 7. So it will run the code first in between the curly brackets. So digital right I, which is its own, the I will become 7. So that's why pin 7 will blink first and then it off again after a 1 second delay and then another delay and then it will go back to this for statement again. So this time it will see if it's still smaller than 9, smaller equal. If this is true, then it will go to this increment. So it will, the original I will plus 1. So from here it will become I equals I plus 1, which means, 1, which means 7 equals 7 plus 1, not 7, sorry. And then equals 8.
It's something like imagine the okay, now since it's the COVID MCO PKP season, right? So for each one, if you want to go to shopping, you need to line up, correct? So imagine three of you and your another two friends are lining up. So first, let's say you are number 7, your another friend, your second friend is number 8, your last friend is number 9. Okay, so for sure, since you're number 7, and by referring to this four statement, number 7 come first because I is initialized. Initialize means starting point. So you're gonna go inside shopping complex, you're gonna do whatever you have to do, and you come out, then only your friend gonna go back inside. Same goes to this statement. when it comes to number 7, the number 7 need to do all the code which has been written here. So it start with high. So number 7 gonna high means number 7 gonna light up.
So it will only run the one that is in the curly bracket. So you click on the curly bracket.
Okay, this curly bracket sahaja.
Yeah. So whatever you type inside here, it will run.
Okay, after the number 7 LED go through everything,
it will
go back to the
here.
statement. If we ask,
It will go back to this condition. So it will check if the condition is true or false. So currently it's still 7, correct? So 7 is still smaller than 9. So means the condition is correct and it will move on to increment.
increment means from 7 it's gonna go to 8.
Yes.
Why? Because it's increment by 1.
So 8, then it will run this process again.
Everything again.
And then it will come back after running. It will come back to
Condition
again and check again. So now it's 8 and it's still lesser and equal to 9, which is true. So it will go to increment and it will increase by 1. So it will become
9.
I equals
So 9.
8 plus 1. So the new I will be 9. So now 9 will run through all the yellow highlighted part, and then it come back to this condition again. So now this condition is lesser and equal to 9, but 9 lesser equals to 9, it only fulfill the equal. It does not fulfill the lesser. So means this statement is wrong. So it will not go to
only one
increment. So it will stop here. But why will it still move on to 7 again? Because you are in the void loop.
Yes.
So maybe let's try to put this whole for statement to void setup, and then you will see the difference. So if you put in void setup, it will only run what we explained just now once.
So what she's saying is after you reach 9, by logically it should stop, right? The LED should not light up. But in this case, it repeat again from 7. Why? Because we are doing all these four statement under the loop. White loop. Loop means repeat. So you're gonna repeat every time until you stop.
So you stop is you unplug.
Unplug. So if you want to see the real for statement function, you can copy this thing and put in void setup. So let us try.
Remember your last curly bracket. Curly bracket.
All of this, right?
No.
This one.
Yes.
Copy. Put here.
Then.
And delete the bottom one, right?
Yes. No, not the last curly bracket. So when you delete, actually it does indicate for you that curly bracket belongs to who. Oh, now yay! Successfully uploaded after restarting the response. Good. Okay, now we shall upload the code
in setup. Okay, check tengok.
So 1, 2, 3. Habis.
Then no more LED.
No more. So setup only run once.
So that's for those who missed out, so we're gonna upload again to show like setup will only runs one because it's not a loop. It won't repeat that. The real function of for statement.
Okay, 1, 2, 3. Finish.
Done.
Yeah, so you're gonna see a continue, then you put at void.
Okay. So that's all for running LED project 2 code 2.
Yes. So how?
Now we're gonna go for
project 3. So project 3 is what's project 3?
Okay, let me go to project 3. Let us open the module first.
So I will unplug the Maker Uno from the USB port and we connect this first. What is happening here?
Okay, this is project 3. Okay, so this is project 3.
So we shall unplug all these. So now in this project we don't need any LED anymore. All we need is just some resistor. So the resistor we used just now is 220, which is not applicable for this project. We will be using 10k ohm instead. So it's the one that have like something like this, but
Black,
it's in brown, black, orange. Yeah,
You guys need 5 resistor of brown, black, orange. Make sure you have that.
1, 2, 3, 4. Right. Okay. Put all this back. Okay, so you get the correct resistor and then we shall connect the same way as the slides. So we are just doing like connecting the resistor to each other, making a row of 1 series resistor, 5 resistor in 1 series.
Yeah.
Oh, sorry. Okay, so now I will connect the first resistor on 30 and 25. Okay, and then another resistor. Since we need to connect them together, so I will connect one of the leg as the same row as the previous leg, which is 25. I'm so sorry, cannot see. Okay, so I will connect this any hole on 25. I think I connect first, then connect first.
Okay, I'll connect first. So you guys also, which type of resistor is it? It is brown, black, orange, 10 kilo ohm.
So I connect one leg here and one leg to 20.
It's brown, black, orange.
Yeah, brown, black, orange.
BBO.
You only have 5 of them. So you can see these 2 legs are connected at the same number. So which means both of them are actually connected to each other. So you do the same for the next 3 resistor. It's a break. So your circuit should actually look something like this. It's okay if you are connecting not the same number as mine. Just do it your way. Just remember that one of the leg of the resistor must be connected to another resistor leg in the same number. So when you're done, please type done or okay or yeah, just type done or something. Okay, so I can see a few of you already done. So the next step is we are going to take two wires or three wires. Okay, three wires. So one, two, and three. So the two wire will be connected to pin 6 and pin 7. And then another wire will be connecting from the resistor out. Okay, so any side is okay to connect to pin 6 or pin 7. So I will connect one wire to the number of 5. So same column. And then another wire at the end, which is 30. Okay, then from here, you can connect this as 7, and then this is pin 6. So, yeah, 7 and 6. Okay, can. Then the next step is just to connect another wire, the same number that you actually connect the wire to pin 6. For mine is number 5. So like this wire is connected to the wire connected to breadboard. It depends on what? What do you mean depends on what? Can you explain what you are trying to ask? Okay, so the breadboard, the alphabet is all connected. I mean like your breadboard is in a way of okay lah, I just draw this is A B C D E 1 2 3. Okay, so if we are looking at only one, okay, the A B C D E are all connected. It's like a wire connected. It's just you are able to plug in another component or another resistor on this uh same number but different alphabet. So Basically, if you are putting A and E on the number 1, they are actually connected. It's the same now. And then if you are looking at 2, it works the same as the number 1. So A, B, C, D are also connected. But if you want to say is 1 and 2 connected together, they are not connected. So it's like the conductivity is just any other color. The conductivity is just so between here there is no connection. No connection. So to connect both of them together is you are going to add a jumper wire here. Did I answer your question? Okay. So let's move on. Okay, so now another wire is we are going to use it for the capacitive touch. So this wire will connect to that resistor leg that is connected to the wire, this wire or this wire, either one. But this wire have to be connected to pin 6. So my 30, this 30, the wire is connected to pin 7. So it's not the one I want. So but for number 5, this resistor leg and this wire are connected to pin 6. So I will connect another wire here at pin 5. At 5. Okay. So this one we will do it later. So now we shall grab a paper, so you can take any paper. Okay, now we use this paper. Take a pencil. You can use mechanical pencil or normal 2B pencil, it's okay. So we will color a patch of pencil. Like you do coloring, you color a patch here with pencil. Basically, if you want to make it as the conductivity of this wire, so you just color something like this. Okay, so this actually works already. So don't connect first because it might actually cause some error if you connect now. So now we shall go to the coding part. Okay, so is everyone okay before we go to the coding part? Say yes, okay, no problem. Okay, so let's open your Arduino IDE software. Okay, can open a new one. Okay, so for this project, you will need to add a library. So what is library? So library is a collection of code which allow you to be able to connect to different components. So some component require some extra codes. So this library is something like they actually already have these extra codes in it. All you need to do is just download and install it into your Arduino IDE and you can use the code. So let's do the process of installing it. So there is 2 ways. So we will do one way first. Or maybe we just do one way, we'll do. Okay, so now we will go to sketch. Okay, so we go sketch and we will go to include library. Okay, so if you are not able to catch up, please let me know, because I might be too fast or too slow for you. So go to sketch, include library, and press manage libraries. So you click on manage libraries. A window will pop up saying library manager. It's not showing. Eh? Okay. It takes some time. Okay. So you can see this. Can you all see this library manager? You see the library manager? I think you all can see. Okay. So from here, okay. So if you look at the code again, okay. So let's look at the code. You will need capacitive capacitive sensor. So include this capacitive sensor.h. It means we are including a library. However, this library might might not be in your software, but we shall try and we will install it anyway. So we go back to our code. So your library manager, we will type the name. So what we want was capacitive sensor. So you type capacitive sensor and enter. Click. Okay, so you scroll down until you see this capacitive sensor by Paul Badger, Paul Stuff Region. I'm sorry if I pronounce it wrongly, but basically the library you will need to install is capacity sensor. So we already installed it initially. So if you haven't installed, you will actually look like this. So you can see the install word at the right side of this capacitive sensor, and then you just choose the latest version and click install. Is everyone okay? Is everyone able to follow? So you just need to go to find capacitive sensor by Paul Badger, and then select for the latest version and install it. Please let me know if I'm too fast or you are still stuck at somewhere before this. So once you install, you will see this capacitive sensor have this installed word here. It means it's actually installed into your Arduino IDE software. Hannah, you mean you don't have it is when you search, there is nothing called capacitive sensor by Paul Badger come out? Okay, then we will do the second way of importing the library. So, okay, so whoever already done, maybe you can also take this as an extra knowledge. Okay, so let's close this first. Okay, so you go to your Google Chrome or your browser. Okay, so now you go to Google and we will search for capacitive sensor library download. Are you here already, Hannah? And maybe everyone else? Okay, so once you are here, you can choose the first one. So it says playground Arduino.cc or Arduino playground or Arduino libraries. It's okay because it's from Arduino. So maybe I will click the second one. So it will, sorry for the extra noise. Okay, so this page is, can say it's a trusted page for you to download library. So you can see it's also by Paul Badger. So the download section, you can see there is shown the release date, which is the latest one was 2016 January 5th of January. So all you need to do is just click on this file and it will download. You just choose your place location to save it, and then we can import it to your software. Yeah, so let me know when you finish downloading.
Oh, there's another way.
I already done the first way.
Oh, okay. This is alternative.
Because Hannah is unable to find it. Okay, so if you are done downloading, we will go back to our code. I mean your software. Oh, sorry. I'm wrong.
Okay.
Okay, so Hannah done downloading? Okay, done. Okay, now others, if you already download, you do not need to import it again. So just for Hannah or those who still unable to get the library. So now you go to Sketch, same thing, go to Sketch, include library as well. And you can see below manage library, there is add zip library. So the file just now that you download is actually a zip file or the WinRAR file. Yeah. So you click on add zip library. So this is like a manual process of adding your library. So you go to just now your location that you actually save. Mine is desktop. Oh. So you can see capacitive sensor dash 0.5.1, and then you just press open. Okay, I'm not gonna press open because I already installed. So Hannah, you press open, and then to check if you have it, go to sketch again, go to include library, and go to contributed libraries. So you will see capacitive sensor here. So is everyone able to get your library? And you can see this capacitive sensor under the contributed libraries. Please let us know if you are able to download it anyway. Yeah, I mean like either ways of downloading, but as long as you already have this library installed into your Arduino IDE. Hannah, are you able to install the library using zip file? Did you get your contributed libraries? Should we click on? Yeah. This is. Wait. Let's check if everyone have the library first.
Okay, can.
Yeah, sure. So we will stop presenting first. Okay, so Hannah, you can share now.
Teacher,
Is it Munir or Hannah?
So Munir, this is correct, but we shall
Can we check?
wait
teacher,
for.
Yeah.
can you see mine is correct or not?
Yes.
Oh,
Yeah.
Munir, correct. Yes.
Okay, thank you, teacher.
Alright. So how about Hannah? You say you want to share the screen? I thought just now it's like to a second. I thought it's Hannah. Okay.
Yeah, and then it's the Munir sharing.
After installing it.
Yeah. We will start the code, but we will check if everyone actually have the library first. Because if you do not have the library, you are unable to run this code.
So in there's one way to check whether your library is there or not is when you type in capacitive sensor, the word capacitive sensor, like how Monet show.
Munir show is include the library.
Include library.
Yeah. So another way is you go to sketch. Just now I've mentioned you go sketch and then it goes to include library, and then you find contributed libraries and you will see capacitive
Wait,
touch.
we didn't share our slide. So, Hannah, you would like to share? Or...
We shall share first.
Okay, so after you install, but you still don't sure that your library is occupied with capacitive sensor or not. Oh, okay. So you just click sketch, go include library and check the contributor library. If you have capacitive sensor, then
Yeah, so now if you have, just click on it now. So it will pop this include
yes.
capacitive sensor.h.
If you have, you just click on the word, then you're gonna have that appear on your code.
Yeah, so then we will start the coding. So let's go back to the slides. So you guys type in the code and we will also type in. Joe, why is mine different? How
different is yours?
How different is yours?
Can I share the screen? Silakan.
Okay, so you guys have to wait a while. So Moise is facing some problem. So we shall discuss first.
Muiz, you can share your screen now. Okay, yes, Moise. Yours a bit different, yes. If you have that, means should be fine, I guess.
Are you clicking? Did you click the example code? I think you click on example code instead of just include library.
So can you click can you find include library in Arduino Droid? The setting or the function include library. You go like maybe you go libraries there. You can see libraries, guys. No, not library example. You click the three dot. Okay, you click library, then manage library.
Not manage library. The first one cannot click.
Cannot. Oh, this one is
This
no.
is adding library.
Available. Go for available library.
I think he already add. Eh, aku got mouse one more. Can I leave now? Because yeah, you may leave now. What is the time now? Oh, okay. Yeah, you may leave now because if you missed out any part, we will.
Hey, can you hold? Can you give us 1 minute? Survey link.
Yeah. So wait. So we will send the survey link here. So whoever are about to leave or other way, so please give us your feedback on this live stream.
Give us 1 second to share the survey link.
Don't leave us first.
What's it?
I cannot. No, I don't want.
Give us a second. We will share you the links. Okay.
Okay, so before you leave, please have us do this short survey, just a few minutes of your time, and
Yeah. So you do fill in the survey, and for those who are gonna leave soon, and those will be with us until the end. We're gonna end soon, actually.
just we will be finishing this project, and then we will end the live stream. So if you are leaving early, if you missed out the part after you leave, you can actually go to YouTube because we will be uploading this live stream to YouTube. I will post the link in the stream. Yeah. And also one more thing is
Oh, our next webinar will be.
oh, you have already responded. Okay.
Our next webinar will be 3 weeks after today. It means gonna be on September, second week of September. So we will be posting a not mini, a checkpoint project, sort of a checkpoint project inside your Google Classroom, so that you guys can work on the project, and then when the next time we meet, you guys still are on track and we will continue on the webinar 4. So that project, the 3 weeks is the duration for you guys to submit the project. It will be simple, quite simple. And it's an opportunity for you guys to explore more and learn more, explore more and learn about how to create a simple project. The project title will be posted inside the Google Classroom stream.
I think on Monday.
Huh.
Yeah, okay, so Ramak, Arun, maybe you try refreshing the page again. I've changed the settings to not limiting by one response. So
okay, so let us continue. So who is this? Okay, Muiz. So I think the teacher, why does it?
okay, I've just changed the change the settings. So please refresh or click the link again. Close the original tab and then click the link again and then respond, and yeah, I think it should be able to respond already. I've changed the settings.
Okay, so let us go back to the code. So this is the code. You can.
He already finished.
Muiz, so you still have a problem on that? I think yours is okay. It's
You
not a
cannot
problem
include.
lah.
So if you
He
cannot,
already have inside.
since you have the example, it's okay. So you just delete the excess one that is not the same as the project one. So you just delete like the.
So Muiz, I think yours is not. There's no problem with yours. You can continue lah.
Yeah, you just like
You delete.
backspace the part that you don't want to see. It's not the same as the one shown.
Okay, so we're gonna share our screen now to continue the project 3. Yeah. So remember, those who are unable to, who have to go out, leave now. So do continue. Go back to our video, pre-recorded video, which will be posted in our YouTube, and we're gonna give you the link in the stream.
Yes.
In Google Classroom.
By today.
Yes.
So
okay, let's
now
go
we
back
will
to the
share the code so you guys can type as well as we type.
Okay, so we're gonna type now.
No space study. So if you're done, maybe we shall wait for others. So
We give around one, okay lah,
2
more
minutes. Yeah. So if others are done, then you type in done, then we can move on.
Okay, so make sure you guys get exactly something that exactly like how we show in front in the screen. So first, how about we run first, we see the result, then we explain.
Yeah. So connect your Maker Uno
So you run first. Before that, make sure you connect your Maker
to
Uno
the laptop.
and you do the configuration. Click tools, click to the correct port, correct COM. Make sure they are connected.
And then we
Okay.
shall upload, verify and
Wi-Fi
upload.
first. Okay, done compiling. Then upload.
So after you upload, you can turn this on. There's a switch. This is for the buzzer switch. So since this code is going to use buzzer because it
Tone.
has tone, then we shall turn it on. So this buzzer is actually pin 8. That's why the code written 8. And then beside it is actually the pitch.
Frequency.
Yeah, frequency, or you can say the pitch of the, what's that?
Of the sound,
Yeah,
the buzzer
sound.
sound.
So now we will test it out. So just now we did this this lead pencil lead patch. So we shall use this wire that was outside and touch the pencil lead patch. It should have sound. Oh, don't have. So if it does not work, then
So
you
we
can
make it a bigger. We
color
need to color
another
bigger
one.
lah. Color bigger. So let's rate her color. So everyone is just watch enable coloring color pens.
Ah, I feel like a kid again. Is this big enough?
Bigger. My finger is bigger. I got this expected all before what? Okay. Expected. Oh, you didn't put your semicolon. So check each line must have a semicolon.
Each statement of code.
Each statement of code, yes. Check.
Okay, let's try.
Okay.
Oh, macam ini mana? Why cannot? My finger cannot detect.
So they should you miss one. If not, they won't really show that error lah. So make sure you check which code line don't have a semicolon.
Wait, touch this camera.
Start from serial begin until delay 50. Check each line.
Oh, oh, Lisa and Ken.
So something like this. It means this LED, the pencil LED can conduct LED current, and human body are conductor also. So and I'm stepping on the ground, which shows that we are
Grounded to
grounded.
the ground.
You need to on the switch, Mune.
On the switch here.
Can I share my
On
screen?
this switch.
Yes, Rama, you can share your screen. Mune, you on the switch. You on the switch.
So another way to test is you hold
Okay, you just touch. If not, Mune can directly touch the wire there.
or touch this resistor, the last resistor that you are connected to this wire.
Wait, let us. Okay, Rama, you can share screen now.
This is funny. I think we need to press harder.
Yes, Rama, you see your capacitive sensor cap sensor 76 equals to cap sensor 76 bracket. After the bracket, there is no semicolon. There need to be a semicolon. Yes, correct. Yep. Now you upload again. Cap sensor was not declared. Your cap sensor spelling is not correct. I think.
I think you have
No,
a
you
space
have a space
in
between.
between your sensor and underscore, yes.
So
So whatever you declare on the
top.
the capacitive sensor, cap sensor underscore 7 underscore 6 have to be the same. It's
You
like,
upload again. You can upload again. Yeah.
oh, I never to get it now. Eee.
Okay, I think that should be good. Right.
So you're able to get the sound. So if you means you need to.
So all of you managed to get the sound. Either you touch the wire directly, or you can get the sound through the LED, or you can touch the last.
LED,
Sorry,
the
LED.
So you need
Cancel LED.
to press quite hard.
Or
If
you
it
can
just-
get the sound by touching the last resistor.
Yeah, like this. Like this. Oh, I cannot. When you touch here. No. When you touch here.
Careful. Okay lah, it's not that
So
dangerous.
you will feel a bit shock, like some electric shock on when you touch your resistor and also your wire. I don't know how I got. Oh my god.
Anyway, so all of you guys can get the sound up. So let's
Explain slightly on the code.
Okay, let's go to the code. Right, so first, if it starts still no sound.
Did you try to touch your LED, your wire? Do you have sound? Okay, then yeah, it works. So this one maybe you need to press harder onto the pencil lid patch. So let's go back to the code part.
Okay, first line. The first part include capacitive sensor. So this line means we activating it. It shows to it is a message to the software that we gonna use this capacitive sensor library. Okay, the second one is declaring a variable. What is the variable we're gonna use to represent the capacitive sensor? Correct. Sorry, you don't need to, so that it will be easier for us to do the code later. And then what setup serial begin is we are setting up a communication between the serial monitor, which is this one.
So yeah,
serial monitor.
So let's also show you the serial monitor when we are conducting.
Okay, this is a serial monitor.
So
See the value.
When I touch,
value increases.
So when it reaches above 100, it will have the tone. So
See?
when I touch here, see, not enough already.
Not enough because more resistor if you touch directly, there is less resistor, so it will easily get higher than 100.
Okay, so let's go back to the code.
Okay, so that is the serial begins for. And then white loop. Okay, long value capacity sensor 30. Okay, so first, now we are just declaring the variable toward as the capacitive sensor. So whenever the value, okay, so any value that is generated by this capacitive sensor, which is already inside the hardware, will be printed out in the serial monitor. That is what serial print ln means. Okay, that is what serial print ln means. And then if the value increases above 100, it will automatically generate sound. So for this tone, why we use 8 as the pin number? Because this buzzer is connected to pin number 8. So whenever you want to activate the buzzer, you need to write number 8 there. Okay. So Mune, my serial monitor just write 2. I see. Okay. Rama, when I put the wire on the lead patch, I could not get the sound. But when I try to yes, because your lead patch is not as higher conductor, or your body have a higher conductor, so the value cannot really exceed 100. All right. So Mune, your serial monitor just write 2 means you need to I still can't get it. Um, can you try to touch the resistor itself? Touch the last resistor, something like this. You get a value higher. It's still 2, is it? What's the case?
I gonna shock. Anyway, please be careful. So I think you check your connection whether all these are actually connected
Yeah.
in the same row. Like these two legs are actually same number. These two legs are same number. These two legs are same number, and these two legs are same number. And this wire have to be to 6 and 7. And this extra wire should be at this same wire that was connected to 6, and then to your that number, and then to this wire. Ouch!
So maybe few of your resistor might really not connected. Yeah. One might be one of the reasons. Make sure all your 5 resistors are connected to each other. So are yours working now, Mune? Uh, can you share your screen, Mune?
Nobody
Alright.
The code seems to have no problem, but maybe you check your connection again. Just check, just maybe unplug one of the resistor and try to plug in again. But when you are doing it, please be careful because there are some like what do you call it? Static electric, so you might get some slight shock. Yeah, just try to still same. No same. Still same, no same. What do you mean still same, no same? No sound. Still -2.
-2 means it's you plug on the opposite direction, is it?
Just try to take one out. Stops completely.
-2 it means you might plug in
Change your resistor. Maybe you will change another pin. Or maybe you'll connect down here. Oh, there I get -2. So this is how I get -2 when it's like this.
So your yes. Yeah.
But I don't know why. So probably one of your resistor is.
It's not really connected properly.
So now.
You try to press a bit inside, make sure your resistor are totally in.
I think you did not connect the resistor properly. Why mine cannot now? Oh, this your pin 6. Did you connect to pin 6? Did you connect the pin 6 to this last resistor? You see, if this LED, this wire connect to pin 6, connect to your last resistor, it runs. If you did not, it will show -2. So check again if your
pin is connect properly or not.
Wire that is connected to pin 6 is connecting to the last resistor. Yay!
Oh, nice.
Yeah. Great job. Oh, we do try. So I think I think that's all for our session today. So
Any question?
Yeah, any question?
Before we give you again the link of the survey for you guys to fill in. So any question?
So if nobody is typing or
So we won't be seeing each other for the next 3 weeks. Instead, we're gonna give you guys a task as a checkpoint for the webinar that you guys have joined. For those who are new, also can try out the task. It's a simple task and something a task which is meant to excite your curiosity.
Yes. So we will post the so-called rules and regulation, not really rules and
Info
regulations,
sheets lah.
information about what you are supposed to do on Monday in stream. So when we come back to the live stream after 3 weeks, you guys are going to present to us on what is your understanding on these projects.
Okay.
Okay.
So make sure you guys are prepared for the presentations.
Yes.
Make sure you can on your video if you have video. If no, at least
It's okay
audio.
lah. Yeah, mic.
Audio and screen sharing should be fine.
Yes.
Okay. All right. So we're gonna post that everything inside the stream in Google Classroom. Now we're gonna give you guys this link and for you guys to give feedback on how the webinar future amendment that you guys can suggest. Feel free to suggest, and the important is be honest when you guys
Write the
Write the
feedbacks
feedback.
for us and also things that you feel need to be improved lah.
Okay, so when you finish, you can just we will wait until you guys finish fill up the form. Then you can leave. Then we will be the last one who leave the web.
So thank you for joining us today. Hope you actually learn some new things like installing all these libraries as well as what's that, troubleshooting together.
And also the 4 statement.
4 statements.
So in wrap today we learned about 4 statement, capacitive sensor installation library, and then troubleshooting on the project tree, and a bit of tone and buzzer.
Yes. So thank you for joining.